Right. Welcome back. I'm going to change the order of the things I was going to do. We're still going to do all of them, but just kind of figuring out things on the fly. We were going to 37. We're going to do like four, I think it was four-ish, roughly 4 questions of that week 4 assignment, which we still cannot finish. My MTH 154 class, we got halfway through 2.4 today, but not the other half. We did not finish talking about the consumer price index. In case you haven't finished watching that, which really should go before this, but you can only do what you can do. Point being, we still can't finish all these questions together, so we'll still probably do a couple next class, next MDE 54 class. But for now, we will get into some of these PE ratio ideas, a couple of math problems, basically just proportions or solving an equation. Yeah, and then after we do that, we're going to do some more of the y equals kx style proportions. And again, remembering that you don't have to do them that way on your own, but I wanted to just see more practice in here since we did lots of fraction equal fraction. Maybe even 1 or 2 we'll do both ways, probably just 1. And then we'll do some time management questions and have some fun with that, assuming that we do have time for all of that. All right. So, yeah, that was just my reminder to do more y equals kx stuff for now. This and this. Can we read everything? Looks like we can. All right. Recall that the PE ratio is the ratio of the price per share to the earnings per share. Now, those wordings, those phrasings, if you will, are very important. The PE ratio. Remember, the word ratio means it's a fraction, so it has to be a fraction. What's the fraction? What are the units? Well, the top is the price per share. And the bottom is the earnings per share. And there are 2 different ways that you can use this relationship. Sometimes, and we did it both ways in the class earlier today, sometimes you're just using the ratio itself and plugging in numbers and reducing them and seeing what you get to actually be the PE ratio. But sometimes you'll know 2 of these things. Maybe you know the PE ratio and the earnings per share, and you're wondering what is the price per share. So then you just call that an X and you solve this equation. Now, the way you do that, you can also just set this equal to X over 1, cross multiply and solve. That's an alternative that is basically how we were doing things in the guided activity. So that's arguably 3 different ways. And that X is not a wrong, that was just saying me if this was the unknown, call it X. Sometimes it's the earnings per share that's unknown, so you would call that your X. Sometimes it's the PE ratio that's unknown. And if this is your X, again, I'm not crossing it out, I'm saying if that's your X, you're literally just doing the division. It's not an equation to solve. Okay, so this is our guiding formula, if you will, that you will have to memorize. The name tells you exactly what it is. PE ratio, not physical education ratio. Price, P, earnings, E. But then you have to remember that both of these are as a per share. All right, so what do we have? Compute the PE ratios of the following companies. A, the share price is $11.25 and the earnings per share is 54 cents. So whenever you're given a share price, that's a price per share. That's just another way of phrasing that. So for A, we have the price per share, which I'm going to abbreviate PPS, price per share. That is the $11.25. And then we have the earnings per share, which I'll abbreviate EPS. That's 54 cents. And they want us to compute the PE ratio, which is literally just divide this thing by this thing. Price per share divided by earnings per share. This is the easiest one. So your PE ratio, which I'll just write PE, is $11.25 divided by ugly dollar sign, 54 cents. We pull out a calculator. We do 11 0.25 divided by 0.54. And we get this ugly number, 20.83333333. They tell us to round to, interestingly enough, 1 decimal place. I thought it was 2 for some reason. Hold on a second. All right, so rounding to 1 decimal, that would become 20.8. Now, it's not dollars. What we're going to talk about in chapter 3 is how units cancel when they're on top of each other like that, but you should get your calculator went away. 20.8. It's actually a unitless value. Let's see if that's right. We got it right. 1 down, 2 to go. Now, A was the easy one, spoiler alert. B, the PE ratio is approximately, well, okay, you might think to just divide the 36.33 and, well, hold on, what do you divide? The 1.5 billion shares or the 4.125 billion in profit over the past year? Okay, well, don't just go willy-nilly multiplying and dividing and adding and subtracting numbers. Don't just do that. Pay what? Attention, that's right. What are we calculating? A PE ratio. What is this? It's the ratio, the division of price per share and earnings per share. We've got to make sure we have both of those values. Do we have the price per share? Well, yes, we actually do. The share price is $36.33. So the price per share is $36.33. But then they say there are 1.5 billion shares. That's not earnings per share. And then they say that the company made 4.125 billion in profit. So profit is another word for earnings, as a reminder. Profit, earnings, literally the same thing, but that doesn't say earnings per share. That would actually be a ton of earnings per share. The fact that these numbers are in billions is generally a clue to say, well, I'm not just going to be dividing these two things. The two things we're dividing are prices. Dollar amount, dollar amount. 1.5 billion shares is not a dollar amount. This is a dollar amount, but it's a ridiculously large dollar amount because it's all of the earnings, it's all of the profit, not a profit per share. So what we have to do is first, I cannot stand when that happens. First, we need to find the EPS, the earnings per share, which is literally the earnings per, which means division, and then the number of shares. What's your earnings? Oh, they don't throw the word earnings in there. Oh, well, no, we can't do the problem. Yes, we can. Earnings means profit. That was 4.125 billion. So since both of these things are in billions, we can just leave that with the units there. So 4.125 billion dollars. And then the number of shares was the 1.5 billion. So 1.5 billion shares. So that's the division we're going to do. The billions will cancel each other out. Otherwise, you would have written 9 zeros, well, 6 zeros for the first one, 125, and then 8 after the 5 for the bottom. Let's clear this. So we got 4.125 divided by 1.5. And we get 2.75. That is our earnings per share. Now, this dollar symbol is in the top. It doesn't cancel anything in the bottom, so that should be a, let me just give myself a little more space. So equals 2.75. And that would be per share. Why? Because the number of shares is in the bottom. There's actually the word shares in here, and that's what we're going to start doing is be really, really meticulous with units starting in chapter 3. But for now, I haven't emphasized it too much, so people not writing those words there wouldn't surprise me. Now we have our EPS. We were given the PPS, so now all we got to do is divide those two things. So our PE ratio, which is again the price per share of 36.33, divided by the earnings per share, which was what we just got, the 2.75. Both of these have the words per share in them, so they would cancel if you were writing those things. I'm not trying to focus on that yet, though. That's another day. So 36.33, then divided by 2.75. And we'll round this to one decimal, so 13.2. So both of these numbers are in the ballpark of that porridge, that sweet spot for the PE ratio we mentioned for the historical average of kind of safety, I guess. But again, that doesn't mean that a company with a PE ratio of 1 or 1,000 couldn't be profitable. It certainly could. A lot of the stock market now is just dictated by consumer demand. And consumers love Amazon. All right, C. This one, I would say, is not the most difficult. I would say B was, but there's still something you have to do. They give us the share price. So our price per share, or share price, is $453.79. That's about what Apple was before they split their price. Again, a split is not a bad thing or a good thing necessarily. It's just a thing companies do. My cough is bad today. All right, so there was our price per share. The other thing we need is the earnings per share. Now, they do give us earnings per share, kind of. Hey, blah, 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 numbers, 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 earnings per share. But you have to be very careful. They gave us 4 of them. Which one do we use? Because we only divide by 1 of them. Which one do we use? Which one do we use? Well, in fact, trick answer, none of them. Also, all of them. I know that might sound weird, but hear me out. So over each of the past 4 quarters, the 4 quarters. So for the first 3 months, say, and it doesn't have to be January, February, and March, but let's just say it is. So January, February, March, they made $2.22 per share. April, May, June, $1.69 per share. July, August, September, $1.75 per share. And then October, November, December, $2.29 per share. Well, it's actually pretty easy. You just add all 4 of those up. If they earned this much the first 3 months, this much the next 3 months, this much the next 3, and the next 3, if you add those up, you'll get your total earnings per share over the entire year. So the total, stop doing that word, earnings per share is just 222 plus 169 plus 175 plus 229. And those aren't that hard to add up, but it's 4 of them, so we'll still pull out a calculator. 2.22 plus 1.69 plus 1.75 plus 2.29. Double check my numbers. My vision's a little off today for lots of fun reasons. 222, 169, 175, 229. Okay, 795 sounds accurate. So the total EPS is 795. Okay, well that was the answer, right? Question mark. 7.95. Spoilers, it's wrong. And I'm not going to read the whole thing of why it's wrong, because I'm just going to go ahead and tell you. This is wrong because that was just the total earnings per share. We were finding the PE ratio. That's nice that we have the total earnings per share right now. We need it for the PE ratio, but it's not the answer. The PE ratio is the ratio of price per share to earnings per share. Price per share was the $453.79 for the dollar amount. The earnings per share we calculated to be $7.95 per share. So let's divide those 2 values. 53.79 divided by 795. And we get 57.08, which would round to 57.1. Let's see if 57.1 is right. We got it. So that was our PE ratio. A little high. I'm not saying that company's not going to make money in their stock market. They could. It's just if you are a person that truly believes in the PE ratio as a quantifier, then that might intimidate you from buying some of that company's stock at the moment. Now, PE ratios change every year. They change every month. They change every day. And the reason they change every day is because their price per share changes every day. So if a company goes from $5 a share to $100 a share because they just announced they have a vaccine to a virus or something like that, that would make their PE ratio go up drastically. And you have this thing known as elasticity in stocks, where whenever you see a crazy increase one day like that, you tend to see a small or large fall in the coming days, maybe not necessarily the next day. But when your stock jumps hundreds of percentage points over just a 24-hour period, usually there's a fallback. It's very rare that a company maintains that momentum. Not the point of this exercise, just having a little fun discussion because I really like this stuff. All right, next. Company XYZ. Oh, I love XYZ. I used to like ABC, but XYZ is pretty cool now. Anyways, company XYZ closed at $54.02 per share with a PE ratio. They gave us the PE ratio, that's different, of 15.48, kind of in that sweet spot. Answer the following questions. How much were earnings per share? And let's just focus on one question at a time. How much were the earnings per share? So we're looking for the EPS. Now remember, PE ratio is the ratio of price per share to earnings per share. They actually gave us the PE ratio, though, of 15.48. That does not go in the top. That does not go in the bottom. It's the number that it's equal to. It's this thing that is the 15.48. They also tell us that the closing price per share is $54.02. That's not earnings, that's price, and it is per share. So that's this thing, which means at the bottom, the earnings per share is the unknown. So that's going to be our X. So we're just going to take this equation, which I will rewrite. PE ratio equals price per share over earnings per share. I wrote it a little ugly because you've already seen the formula. You should have written it down by now at least 4 times, 3 times, 2 times, whatever. So what do we have? We have the PE ratio of 15.48. That again is the left number. So that's where the 15.48 goes. How do I know that's where it goes? Because I read and I paid attention and I put the pieces of the puzzle where they go. Circle goes in the circle, square goes in the square. So 15.48 is the left side. All right, price per share, we also knew it was the $54.02. It was the earnings per share that was the unknown, that's the X. Now, this is a type of equation that you may have not ever seen in your traditional algebra classes so far, at least not in this format. You've seen it. There's just one thing missing to make it something you've seen, and it's something we've also seen in this course. So far, our variable's usually been in the top. If it was on the left side, you just do the division and you get your answer, and that's what we saw in A, B, and C. If your X was where the 5402 was, you'd multiply both sides by the bottom number, which it's not a number in this case, to get rid of it, and you'd be done. This is a little different. So what you should actually do is turn this into something else. 15.48 equals the 5402 over X. Let's take the 15.48. Any number you can always write over 1. Why would I want to do this? Because now I have it written as a proportion, so we can cross multiply. So when we cross multiply, we get the 15.48 times the X equals 1 times 5402 is 5402. I'm going to drop its dollar sign just for simplicity's sake. Divide both sides by 1548. And that will give us our answer of X is equal to, what's that, 3 and some change. Let's actually do it, 5402 divided by 15.48 0.48. Let me check my numbers since I'm going with one eye right now. I'm not even being sarcastic. 5402, 1548. All right. Drum roll, we hit enter. We get 3.489. They asked to round to the nearest cent. This is a dollar amount. Remember that X was in earnings per share, so that should be 3.49 since we're rounding it to the nearest cents. 3.49. So that means if you owned one share of that company, you would get $3.49 for owning that share of the company. If you own 10 shares, you'd get $34.90. Based on the fact that this company historically trades at an average PE of 12 to 14, does the stock price seem overpriced, underpriced, or about right? So I might disagree with what they say because 15 is technically higher than 14, but they're only one off, so I would say about right, especially because of the use of the word about. If this PE ratio was something like 20, I'd say it's a little over. If it was something like 10, I might say it's a little under. And that is exactly what I expected if you heard me. So about, the use of the word about, and I predicted this was what's going to happen. Again, I disagree with this. About 15.5 is about 14. It's not that far removed from it in general practices. So this is a type of question that you wouldn't see on a test unless the numbers were much further apart so that this silliness wouldn't happen. So we got that right. As I said, I expected them to say that it was overpriced, but in reality, my math lab is wrong in my opinion, and it is about right. Because again, 15 is about 14. No offense meant by this term, but you know, we have the common the Valley Girl or the West Coast phrase like, you know, and she was like, and he was like, and they were like, and they were like, you know, it's basically, instead of saying he said and she said, it's like. Well, like in a much more appropriate use, 15 is like 14. It's close. About and like are not synonymous. They don't sound the same. What's the other? I'm bad with words. They're about the same meaning. So like, about. So 15 is like 14. Approximately, roughly, estimation, things like that. Okay, so I do want to do the next two questions, even though I haven't fully completed talking about consumer price indexes. Because I did start to talk about the concept of it. So decide whether the following statement makes sense or is clearly true, or does not make sense or is clearly false. So true, clearly true, or sorry, makes sense is clearly true, does not make sense, clearly false. So what they're saying is, we don't know if it's true or false. They're saying the price per gallon of gasoline has risen only from a quarter in 1918 to nearly $3 in 2009, thereby making it much more difficult for the poor to afford fuel for their cars. So in 1918, gasoline was about a quarter. It was about 25 cents per gallon. That's what they're saying. I'm not fact checking that. 100 years later, roughly 90 years later, it's about $3 a gallon. And we're in that ballpark right now as well when you consider all the different types of fuels. Yes, it's closer to 2 currently, but gas tends to fluctuate about 50 cents up and down over a year on average, unless something crazy is going on, like the fuel supply to the East Coast has been cut off, like in 2008 when it went from, what was it, like $1.50 a gallon to $4 a gallon in like a week. Whew, did not like filling my tank up then. All right. So the price of gas was 25 cents in 1918, $3 a gallon in 2009. Therefore, it's much more difficult for poor people to afford fuel in their cars. Does it make sense or not? Now you might say, well, poor people do have a hard time putting fuel in their cars. Poor people might not even have a car. But you're trying to stretch the argument to something that's not here. They're just talking about the price of something one year versus another year. So let's see what our options. The statement makes sense because even with inflation taken into account, the price per gallon of gasoline in 1918 was much less than the price in 2009. We have not done any CPI calculations yet, So that one might be tough to confirm whether that's true or not, but let's assume it's false for now, or that A is not the answer. And let's read the rest. The statement makes sense. Gasoline is 12 times as expensive today compared to 1918, so it makes sense that it is more difficult for the poor to afford fuel for their cars. Okay, that's 12 times, that is about roughly right, 25 cents versus $3. But it's not accounting for inflation. See, this word mentioned inflation, this one, I think I said word, this A, this answer, but then this one didn't. So I don't know about B. C, the statement does not make sense when inflation is taken into account, the two prices are quite comparable. So again, we haven't necessarily looked at prices of things in the past and versus now, but I think a lot of you should have at least heard this from your elders or just news passing, whatever, like you see comic books. It might have been 10 cents in the 1960s when they were first becoming more widely popular. I know they were made before then, and now, unfortunately, I'm not a comic person, but they're probably about $3 each now. So they went from 10 cents to $3. That's a pretty big jump. It's about the same jump as the gasoline, but it's not like people can't afford comics anymore. So the statement does not make sense because when inflation is taken into account, the two prices are quite comparable. And this is a long year, 90 years for prices to have inflated from a quarter to $3. I don't know, I'm kind of thinking C might be it, that it doesn't make sense because inflation would take that price from 25 cents to $3 over 90 years. Next up, the statement does not make sense because poor is too vague a description to be meaningful in this context. A lot of people might want to say D for argument's sake, but it's definitely not. Let's see if it's C. And that's what I expected. That was correct. The statement does not make sense because when inflation is taken into account, the fact that the price of goods tend to go up on average every year. When you look at a year by year, they go up by small amounts when you're looking at every consumer good possible. But when you look at 90 years, that price, all those little small increases will add up to a big increase. Now, yes, if you have a meat shortage or something like that, the price per pound of hamburger might go from $4 to $8 in 1 year just because supply and demand has changed. But again, that is literally just one consumer good. When we're talking about inflation, we're considering all things, and we like to pretend like all things are inflating equally, even though we know they don't. Some things go down. I can tell you when I was in college in the early 2000s, I was buying gallons of milk, and these weren't organic, for like $5 a gallon. Now I can get a gallon of non-organic milk from the grocery store for like $2.30, $2.40. It's actually about half the price. But that's not because our prices have deflated over the past almost 20 years. It's because that one good has deflated in itself. Why? Well, it could have to do with farm subsidies. That's a complication in things, especially with food, especially with vegetables, meats, things like that, plants, fruits and vegetables, that is to say. I don't think the price of bananas, again, non-organic, it's a big difference, has gone up in the past decade at my grocery store. I don't think I've paid, I think I've paid the same price for a loaf of bread at the grocery store. I don't really buy bread anymore, but that's a whole nother bag of beans, pun intended. All right, so next. But my bacon that I buy, that's like doubled in price because bacon became higher demand. It became a shortage at one point, and they just kind of kept the prices where they were. Bacon wasn't even a high demand meat until, what was it, the 70s or 80s? And I read somewhere that Wendy's was part of that, that they had like a bunch of bacon left over and they started throwing it on burgers, and then all of a sudden, boom, everybody wants bacon more. I don't know. You can fact check that for me, but otherwise it's just a silly little discussion. All right. Decide whether the following statement makes sense or does not make sense. Explain your reasoning. I love this question. I love it so much, I actually put it on a test once. An 18th century philosopher once said, "A penny saved is a penny earned." But if he were alive today, in the 21st century, so at least 200 years and some change more later, he would be talking about a dollar rather than a penny. So choose the following. The statement makes sense. Due to inflation, a penny in the 18th century has about the same purchasing power as a dollar today. You can actually take that gasoline problem from like 100 years in the past and kind of go from there. Over 100 years, gas went from, let's just call it 30 cents to, instead of a quarter, for the sense of, where is it? I really am looking with one eye. I've got my other eye closed. There it is, a quarter. So it started as a quarter, let's just call that 30 cents, and it went to $3. So over about 100 years, gas went up by about a factor of 10. If you multiplied 30 cents by 10, you'd get $3. So over 100 years, it multiplied by a factor of 10. So if we're looking at least 200 or 300 years, there would be a bigger jump than that. So a penny might have the same purchasing power as a dollar. Now you might say, well, maybe it's only 20 times, maybe it's only 30 times, maybe it's not A, so let's hold on to that. Remember, don't just A and check your answer, read them all. These multiple choice questions are meant to have some, what's the word I'm looking for? They're meant to make you think, and it's meant to, a lot of them are designed so that it seems like two answers could be right. So the statement makes sense. Due to inflation, a penny in the 18th century has less purchasing power than a penny today. Now, this statement right here that I'm highlighting is accurate. Due to inflation, a penny in the 18th century, which might have bought you a loaf of bread or something like that, is going to have way less purchasing power than it would today. I mean, what does a penny even get you? You can't even get a piece of gum for a penny now. We've had a lot of discussions in mass about not even making the penny anymore. I mean, we're going through a change shortage right now, and a lot of people don't even seem to care that much, right? Now, if you're missing some quarters, that's a big deal. A couple of pennies, whatever. You know, just give me a nickel back instead of 7 cents. I'm okay without the 2 pennies. So here's the problem. Even though that highlighted statement is correct, it says that the original statement makes sense, and the original statement says that a penny saved is a penny earned. So I don't know about that. All right, the statement does not make sense. Due to inflation, a penny in the 18th century has less purchasing power today than a penny today. So this actually seems to be the contradiction to be. It's got the same statement attached. A penny in the 18th century has less purchasing power than a penny today. So these two things are, it's got the same statement. One it says makes sense, one it says doesn't make sense. Let's think about that. And also let's think about the purchasing power. It's not saying the purchasing power in the 20th century. It says it in the 18th century. So that penny in the 18th century got you a loaf of bread. The penny now gets you nothing. So let's go back and read that again. Due to inflation, a penny has less purchasing power than a penny today? No, it actually has more. So this statement is flip-flopped. Due to inflation, a penny in the 18th century should have more purchasing power than a penny does today. So those statements are actually very wrong. All right, the statement does not make sense. The value of a penny is always 1 cent. Okay, yes, the value of a penny is always 1 cent, but inflation causes the value of that penny to change over time to be able to buy you a loaf of bread initially, and then no longer be able to buy you a loaf of bread. It seems like A was the only answer that made any kind of sense. Maybe it was C, maybe it was B, but it was A. I think this is the one I wanted to say for last time. Oh, reading with one eye is fine. Is this the one I was saving for next time? Yes, I do want to save this one for next time. Okay, so that is it for that section of problems. So before we go on to, because I got about 25 minutes left, before we go on to the other types of problems, we even have time. We probably won't. We'll do the time management next time if so. So we'll save that. But for now, I wanted to do more of those y equals kx types of problems. So that's what we're on now. So example, let's just call it 1. And I really like fruit for this just because it's simple to do. A store sells 11 apples one day and 77 oranges on Monday. If the fruit it sells is always proportional, it sells 18 apples on Tuesday, how many oranges does it sell? That's going to be part A. So let's go, we'll do that and then we'll put up part B after that. Okay. So a store sells 11 apples on Monday and 77 oranges on Monday. I didn't have to say on Monday twice. I could have just said 11 apples and 77 oranges on Monday. Oh, I hope my dog is not about to have an incident. Okay. All the distractions, right? Sorry, my students. All right, store sells 11 apples and 77 oranges on Monday. So we're talking about apples and oranges. If the fruit it sells is always proportional, so that tells us that we can use y equals kx. They're always proportional. Now I've called the y and x apples and oranges, but I haven't written it anywhere. Which one do I want to call apples? Which one do I want to call oranges? Technically, it doesn't matter. I have mentioned that for direct proportions, it does not matter which one you call y and x as long as you're consistent. You just might find a different value of k in that process. So I'm going to choose to call x the apples and y the oranges. On Tuesday, I chose to call x the apples. I chose to call y the oranges. If you want to call y the apples and x the oranges, that's fine. You would end up finding a different value of k than I would, but you should end up getting the same answer for how many oranges it sells on Tuesday at the end of the day. All right, so let's run the first scenario through. Let's do the 11 apples and the 77 oranges. So the 11 apples would be the x, the 77 oranges would be the y. So the 77 goes on the left equals k times the x was again 11. Oranges, apples. Pay attention, put things in the right place. A lot of people really like to write the 11 before the k. I know I do. I don't always show that, but it is better written this way. 77 equals k times 11, same as saying 77 equals 11 times k. So then what we're going to do is we're going to have to divide both sides by 11 because that's 11 times something. To undo it, we divide. So let me just go over here. 77 divided by 11 is 7. So 7 is equal to k. This is our constant of proportionality. That was the name of this thing. That's the constant of proportionality. What this says is for every 1 of x, there's that many of y. So k states for every 1 of x, there's that many of y. For every 1 x item, there are k of the y items. Hold on, give me like 60 seconds. All right, I think I calmed him down. All right, so again, for every one of the X item, there's the K, that number of the Y item. So more specifically, we're saying for every one, looks like Uri, for every one apple sold, they sell 7 oranges. So if there were 2 apples sold, that means 14 oranges. If there were 3 apples, 21 oranges. If there were 4 apples, 28 oranges. You can actually roll through multiples and multiples of 1 very quickly with that idea. You just keep adding 7, keep adding 7, keep adding 7. But unfortunately, this isn't a nice clean multiple. We're not going from 11 to 22, for instance, or anything very easy. We're going from 11 to 18. So now what we need to do is plug the 18 apples into the scenario, but we also know that K is 7. Those are the 2 things we're going to plug in. In fact, I'm going to rewrite the y equals kx. I'm going to rewrite this now as y equals 7x. Again, that says for every 1 apple sold, 7 oranges sell. Now we plug in the 11 apples. 11 was x, so that's 7 times, not 11, excuse me, 18. We're talking about Tuesday. We know 11 apples led to 77 oranges. We're talking about 18 apples, so it's 7 times 18. 7 times 18, which is 128. So it's not just 128 is the answer. That's wrong. It's not wrong, but it's wrong in a quantitative sake. It's 128 oranges. That's the real answer, and you can even be more specific on Tuesday. So if it sold 18 apples on Tuesday, how many oranges did it sell on Tuesday? 128. Now remember that if one thing goes up, the other thing should go up with this idea of direct proportionality. So we went from 11 to 18 apples, which is us going up, and we went from 77 to 128 oranges, which is us going up. So that makes sense. All right, let's try another one. The exchange rate of US dollars to euros is proportional. Fact. Yeah, you'll pay a small fee when you exchange currencies unless you have a nice fancy credit card, which nice fancy credit cards aren't as hard to get nowadays, but you gotta still have to have a decent credit score. So the exchange rate of dollars to euros or any currency is proportional. Now I'm going to make this up on the spot. I don't know the exact exchange at the moment, but let's say if $4 gets you 5 euros, how many euros could you get? We're ignoring the exchange fee. How many euros could you get for $450? So every $4 gets you 5 euros. Someone else might say, all right, every $1 gets you 1.25 euros. I almost said dollars twice. That would be the same proportion. 4 to 5 is the same as 1 to 1 1/4. But that's not what I gave you. All right, so here's what we can do. We can say, well, it's proportional, so we can write y equals kx. But we got to call y and x something very specific. Now again, which one I call which doesn't technically matter. I'm going to choose to call the USD, the US dollar amount, the x, and the euro amount, the y. So when I plug in the 4 and the 5 for the first scenario, the 4 is the x, the 5 is the y. So we get 5 equals k times 4, which is the same thing as 5 equals 4 times k. To solve that, be careful, pay attention, divide both sides by 4, and 5/4 is 1.25. So 1.25 is equal to k. So that says for every $1, you get 1.25 euros. So if you turned in $2, you'd get 2.50 in euros. If you turned in $10, you'd get $12.50 in euros. But we didn't ask any of those. We want to know, what do we get for $450? This sounds like we're going on a vacation and 450 is our fun money. But now our y equals kx, we know the k, so we can just plug that in. It's now and forever, y equals 1.25x. And then just plug in the 450, which was the dollars. So that should go here. Now, I could have asked you how many dollars could you get for, say, 1,000 euros. The 1,000 would be plugged in for the y, and you would have to divide by 1.25. So just watch out for algebra. But this will be y equals 1.25 times 450. 1.25 times 450. And we get 562 and a half. 562.5, maybe 0.50 because we're talking money, and give the exact type of money we are talking about, euros. An alternative way to have done this. I copy the question and put it just a little lower. A lot way. The alternative way is we could have used a proportion table or a ratio table. Ratio table, proportion table, same thing. Let me just zoom back. All right. So we got the answer using the y equals kx setup. Now let's try it using it a different way, because like I've said, at the end of this course, it doesn't matter which way you do things as long as you learn one of them. So what are the things we're converting between euros and dollars? So let's have a column for the USD. Let's have a column for the euro. I'm creating this right now. This wasn't given to me, I'm creating it. Now, there's going to be 2 rows worth of data, as we'll see. The first one was $4 gets you 5 euros. So this was basically the exchange rate. Maybe you want to write the word here, rate. You don't really have to. You can keep these labels completely blank. That's not a necessary thing, because if you're setting up a proportion table, all you really need are the numbers. So $4 got us 5 euros, and they say, well, how many euros can we get with 450? So the 450 is another scenario, so another row, and the euros is the x. Then all we do is we imagine ourselves drawing a box with 4 corners where 3 have numbers. There's not really any thinking to do here. That's it. 4 over 450 equals 5 over x. And again, you could have had words here. This was the currency exchange rate, and this is what we brought. You could write pocket, brought. I don't care what you write for the label. Nobody cares. You're going to cross multiply. You're going to get 4x is equal to 5 times 450. If you do 5 times 50, you'll get 2250. So you get 4x is equal to 2250. You'll divide both sides by 4. When you put that in your calculator, divide by 4. Look at that, you get 562.5. The same exact answer. How can you tell what units it is? X was here, that is in euros. Same answer. Unless the problem asks you what is K or what is the for everyone, you get this of how many other things, it would not matter which way you set this up. So if you just don't like tables for some reason, you can take any table and turn it into a y equals kx as long as you write down what you're calling each variable. And as long as you're pulling things from appropriate places, so that means you still have to understand the idea of a table. I am going to guarantee I give you at least 1 or 2 of the table problems on that first test, the midterm. And they're not usually small like this. They're the style where where it was like this. Now, it's not this ridiculous, but there will be blanks, and there could be way more numbers in there. I could have given you all sorts of, that was supposed to be an 8. I can give you way more numbers than this. And we will see examples of that in our homework. We'll see at least one in our notes next class when we start talking about CPI a little more specifically. In fact, for our example 3, probably the last one we do today, price of a, what do I want to do? Calligraphy set. The price of a calligraphy set back in 1920. Now let's go 50. 1950 was $3. If the CPI of 1950 was 83, and the CPI, Consumer Price Index is what that stands for, of 2020 is 152, what would the price of the calligraphy set now be? Only due to inflation. The price of a calligraphy set back in 1950 was $3. If the CPI, I want to make the CPI of 2020 a lot higher. Actually, let's go 192. 192. Sorry about that. 192. So the price of this calligraphy set, not saying it's a good or a bad calligraphy set yet, just it's priced $3 in 1950. And the CPI in 1950 was 83. So this is just a number that you would find from a table. I made it up on the spot. It's not 83, nor is 2020 192. But if it was, then that would say that if you only considered inflation, you didn't consider the fact that some goods drop in value, we're going to say that the calligraphy set scales exactly with inflation. No store is just marking it up for, the point of extra profit. So how much would this set cost now in 2020? Only due to inflation. Now, what some people will accidentally use is the years. The years are labels. Do not use the years in your equations at all. They are labels. All right, so we said that we're talking about CPI, even though I did not use the word proportional in there. Anything that discusses CPI, we're assuming proportionality. So we are assuming that these are proportional, so we can do a y equals kx setup. The two things we're talking about are prices and CPIs. So which one do you want to call which? I'm going to choose to call the CPI. It looks like an E. Why did I write an E? Probably because I'm Popeyeing right now. I've got one eye closed. The CPI, let's call X. And then the price, let's call Y. Now, how do we know what numbers to pair together? Well, based on the year. 1950 was a $3 price and a CPI of 83. So let's put those together. So for the 1950, the Y was the price, that's 3 equals, K is K for now, and the X is the CPI of 83. Now we're going to have to divide both sides by 83. I'm going to skip the rewrite this time. And then 3 divided by 83 is going to give us an ugly decimal. And I don't want to round this simply because if I round it, then there will be rounding error. Now, if I round this to 5 or 6 or 7 decimals, that's not too bad, but I'm just going to leave this as 3 over 83. K is equal to 3 over 83. There's nothing wrong leaving these as fractions. So our equation, we can now write y equals, instead of kx, 3 over 83 times x. Finally, we go to the 2020 scenario, which was a CPI of 192. CPI is x, so plug that in for the x. So we get y equals 3 over 83 times 192. Well, there's no algebra to do there. We just got to multiply and divide. So we take the 3 divided by the 83 times the 192, and then we'll round this value. We're talking money, so to the nearest cents, 694. That's a 6939, so 694. And that would be in dollars. So our set is now about $7. It's a little more than doubled in price. Probably not a fancy calligraphy set. This is probably like some markers or colored pencils. Like I said, I didn't say what quality it was. This isn't like a feather tip quill pen. You might have been thinking that because we're talking about the past, but it wasn't 1700s, it was 1950. I don't think feather tip pens were still that popular then. Did you have to do this problem that way? Nope. I'm not going to rewrite the question this time because there's no break. The alt way using the table, here's what you do. You have a column for your CPI, and you have a column for your price. And then your two different rows, if you want to label them, are just the years, 1950 and 2020. Again, don't use those for table calculations. You should not be drawing boxes around that. Right, the CPI's in there. The CPI's for 1950 was 83. For 2020 was 192. The prices that we have, we know in 1950 it was $3. That makes this the X. So we do 83 over 192 equals 3 over X. We cross multiply, which gives us 83X is equal to 192 times 3. 192 times 3 is 576, so that's 83x equals 576. We divide both sides by 83, giving us our ultimate answer, x equals, I bet you already know it, I hope you already know it, divide by 83, drum roll, 6.939, which is 694, x was still $1 not for a price, same answer. Checkity check this out. I'm going to do this a third way. I'm going to do it with another table. Some people say, well, why did you choose to do the CPI this way and the price this way? Why didn't you make those the horizontal? Okay, let's do it that way. So let's do CPI and price. I can flip-flop the order of those, it doesn't matter. And it's just now I'm doing the years as 1950 and 2020. Those are the verticals. Well, the CPI for 1950 was the 83. The price in 1950 was the 3. This CPI was 192. This is our X. You're going to get 83 over 3 equals 192 over X. It doesn't look like the same proportion. These two things have swapped places. But check it out. When you cross multiply, you get 83X equals 3 times 192. The same thing. You'll get the same answer. So when you're creating these tables, if that's the way you choose to go, you've got a little bit of leeway. What you call the row and what you call a column doesn't matter as long as everything's going in an appropriate place. Now, depending on how much information we have, if we had a whole boatload of years, you'd probably want to stack the years like the top way. If I had a whole bunch of different goods instead, you might want to do it the red way though. It just depends on what you got. All right, so we did more practice with the direct proportions. We showed that it doesn't matter whether you do a table or whether you do the y equals kx setup. But remember, these are for direct proportions only. These are interchangeable methods. So, and I don't have time, so if I gave you an example and said blah, blah, blah is inversely proportional, blah, blah, blah. Can't use a table setup. Only use, and this isn't y equals kx because of the inversely word. It's y equals k over x. It's really no more of a complicated problem. It's just this idea is as one thing goes up, the other goes down. More specifically, as one thing doubles, the other halves. All right, so on that note, we're going to call it a day. Thank you for
Sorry, I had to cut it there because I was about to say something wrong in the video. So yeah, per usual, thank you for showing up. Please stay on top of the homework. Remember that the homework assignments in the MDE 54 shell are counting as your attendance as well. So you have to participate in those per usual. I'm not asking for 100% or 90% or 80%, just participation, get some stuff done, make sure I'm seeing that you're practicing, and we have no issues. So y'all take care, and we will see you on Wednesday.